So what is algebra anyway? Hey, how are you?
Good.
I have a question for you. What is algebra?
Isn't it like a fancy sandwich or something?
Hello, Charlie.
Hi.
Hey, I have a question for you. Is that okay?
Uh-huh.
What is algebra?
I think it's a purple fish with wings. I don't know. I think that's it.
Okay. Hi, Maya.
Hi.
Hey, I was wondering if you could answer this question. What is algebra?
I think it's a kind of pizza.
Those are all good answers. And guess what? We get to figure it out together. Yay! Let's start with some variables and expressions. We need to look at some terminology first. I think perhaps this idea looked better in my head. But some words that we can use for addition are sum, more than or greater than, plus, and increased by. Words for subtraction include difference, less than, decreased by, and minus. For multiplication, we use product, times, equal groups of, and multiplied by. For division, we can use quotient, divided by, or split into equal groups of. So why do we care? Well, try these two. Can you figure out the words that would match these expressions? Pause your video. For the first expression, one possibility would be 7 less than the product of 2 and x. And for the second, you could say 4 times the sum of x and 3. This blob represents real numbers. And I'm going to divide this big blob into, we're going to have rational numbers and irrational numbers. Rational numbers are numbers that can be written as fractions. Those numbers can be written as a decimal, like a terminating, which is a decimal that ends, a terminating decimal, or a decimal that repeats. Okay, so rational numbers. That includes like your counting numbers, like 5, because 5 can be written as a fraction, 5 over 1. Okay, so rational numbers, those are most of the numbers that we think about. Okay, irrational numbers would be numbers that they do not terminate or repeat. Okay, I'm going to say this would be something like pi. You know how pi goes on and on forever, but there's no pattern. Okay, so pi is an irrational number. Also, if you take the square root of anything that is not a perfect square, that's an irrational number. For instance, if we take the square root of 7, it is 2.64575131. It keeps going on and on forever, but there's no pattern. So the square root of 7 is an irrational number. Okay, now we're going to go inside of this blob. These are called integers. Okay, and integers are positive and negative counting numbers. So like 1, 2, 3, 4, 4, -1, -2, -3, -4, 0. Those are all integers. Okay, but like even though -1/3 is negative, it does not make it an integer. It has to be a positive or negative counting number. Next, inside of this blob, we're gonna have another blob. These are whole numbers. And whole numbers are the counting numbers starting with 0. Okay, so this would be like if you're counting your M&Ms. Okay, okay, and then inside there, there's one more. Okay, one more little blob that we're going to draw. That's the natural numbers. Okay, and natural numbers are the counting numbers starting with 1. Okay, so here's a little test. Let's see if you know these. Start with -3. Where do you think -3 goes in the big blob? Yes, -3 is an integer. So -3 is an integer. It's inside the rational numbers, so it's also rational and it's also real. Okay, but real numbers are all, I mean, all of our numbers are going to be real numbers. We aren't going to talk about imaginary numbers in Algebra 1, but that will be something you'll talk about in Algebra 2. Okay, 25 hundredths, or 0.25. Where does that go? You're correct. It's a rational number. Okay, it could be written as a fraction. That's the same as 1/4, but it is a terminating decimal because it stops. 1/2. That's right. It's also rational.
4. Yes. It is a natural number, so it's also full, it's also an integer, and it's also rational. The square root of 64. Is that irrational? Because it's a square root. The square root of 64 is 8, and 8 is irrational. Then, square root of 7. I want to skip this one. But we know that that is irrational because the square root of 7 is 7 is not a perfect square, so we're not going to get a number that repeats. 5. Also irrational. Yay. 0. This one's tough.
0 is a counting number that starts with 0. It's not natural. Okay? 0 is actually the only number that would only go inside here, but 0 is a whole number, an integer, and a rational number. And then -1/2. It's not an integer because it's not a counting number. Okay? Even though you might get a broken M&M, you're not going to count 1/2, and it's negative anyway. You can't eat something and it would be negative anyway. That is a rational number. All right? Good job, guys. So now we have these lovely integers and we get to do things with them, like adding them. And we have a beautiful song. And it goes to the tune of Row, Row Your Boat. And I'll be the first to say that I'm not a good singer, but I'm going to do it anyway because I want you to learn this. So this is how it goes. It goes same signs, add and keep, different signs, subtract. Keep the sign of the higher number, then you'll be exact. So if they have the same signs, such as 2 plus 2, because they're both positive, you add the numbers, 2 plus 2, and keep the sign. They're positive, so it's a +4. If they were both -2, then -2 plus -2, same signs, add and keep the sign, we get a -4. Okay? Okay, so here is an example of adding with integers. And here, if you go through the song, same signs, add and keep. Nope, not same signs, different signs, subtract. So we're going to take 12 minus 5, and we get 7, right? And then we take the sign of the higher number. The higher number is 12, so it's positive. So there we are. Okay, then we get to subtraction. And subtraction, I usually say you can add a little positive anywhere. So if you're not sure what to do with subtraction, you can just add a little positive. So we could do -7 plus -3, and then you go through the same addition rules, same signs, add and keep. So you just have the same signs, so we would get -10 here. Okay, you could also think, all right, well, it's -7 degrees, and if I go down 3 degrees, we're at -10 degrees on the thermometer. Okay, so a thermometer also helps. Okay, whatever works for you, you use whatever tricks work for you the best. Then we have minus a negative. Remember, if you subtract a negative, that's the same thing as adding a positive. So positive 6, oh, there went Sunny. Positive 6 plus a positive 4 would also equal 10. Okay, so adding and subtracting integers, it's a piece of cake. All right, now multiplying and dividing. Okay, multiplying and dividing integers, we have the same rules. Okay, so if you're multiplying or dividing with the same sign, your answer is always positive. So we have negative 3 times negative 7, they're both negative. Okay, so we're going to get a positive answer. So 3 times 7 is 21. So negative 3 times negative 7 equals 21. And then we have negative 4 times 5. They have different signs, so we're going to get a negative answer. If they have different signs, when you're multiplying or dividing, you get a negative answer. It's negative 20. All right, and it works with division. So then well. Negative 10 divided by 2 is negative 5, and negative 10 divided by negative 2 would be 5. This brings us to the order of operations and something called PEMDAS. I wonder what those letters stand for. PEMDAS. I bet you could think of something. I bet it could just come to you anywhere. Oh! People eat my daughter's awesome sweets.
Pigs, elephants, monkeys, dogs, and snakes. Ay, 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 yeah! Please exercise my dog at sunset. Pack eggs, milk, donuts, and sandwiches.
Well, those are all good guesses, but it actually stands for parentheses, exponents, multiplication and division, addition and subtraction. Multiplication and division are done whichever comes first from left to right, and same with addition and subtraction. This is the order of operations.
21.
Try these. Pause your video. So how did you do? For this first one, inside of the parentheses, we have to do the division first. So 8 divided by 2 is 4. 4 plus 4 is 8, right? So then we take 3 minus 2 times 8. So we have to do the multiplication first. 3 minus 16 is negative 13. Then when we move down to this next one, we're going to do the exponents first. So we get 9. So, and then we take the 2 times 6, which is 12. So we end up with 12 minus 9 plus 12, or 3 plus 12, which is 15. I was just going for a walk and I found a whole bunch of numbers. I wonder what this is about. Hey, I think this is the commutative property of addition, because you can change the order of the numbers in addition. Can you do that in subtraction? No, I didn't think so. Oh, and look here. This is the commutative property of multiplication. Wow, I bet these are all the properties. Oh, I'm looking at, there's the associative property of addition. 2 plus 4 plus 1 is the same as 2 plus 4 plus 1. 6 plus 1 is equal to 2 plus 5, both 7. Oh, cool. Oh, and wow, here's the associative property of multiplication. 6 times 2 times 3 is equal to 6 times 2 times 3. 12 times 3 equals 6 times 6, both 36. Let's see if there's some more up here. Ooh, 4 times 1 equals 4. So if you multiply 4 or any number times 1, you get that any number. Ooh, identity. Identity property of multiplication. Let's see if we have the identity property of addition. Oh, we do. There's the identity property of addition, because if we add 0, we get the same thing. Let's see another one. Oh, multiplication property of 0. If we multiply by 0, we always get 0. Oh, here it is. The multiplicative property of -1. We take a number times -1, we get the opposite of that number. So 2 times -1 is equal to -2. But then if we take a negative number times -1, we get the positive of that number. Huh. These numbers were kind of hard to read, but I think they served their purpose. All right, yay for properties. And we can't forget the distributive property. If we have 3 times the quantity x plus 5, then we will take 3 times x and 3 times 5, and that will give us 3x plus 15. Okay, so I'm over here in the garden, and I see 1, 2, 3, 4, 5 pumpkins here, and then 3 tomatoes, and then 3 pumpkins. So 5 pumpkins plus 3 tomatoes plus 3 pumpkins. So I combine them all together and make pumpkin ketchup or pump up? Nah. I don't know. Pumpatoes? I don't think anything can beat Plumplesauce. I tried. So, 5 pumpkins plus 3 tomatoes plus 3 pumpkins equals 8 pumpkins plus 3 tomatoes. You did a great job with Chapter 1 of Algebra. Let's celebrate with some Plumplesauce.